Hi Year 10, this is Mr. Havenhand. I'm just going to go through the answers to the pages on averages and the range. This is page 5 and 6 of the Data 1F pack and page 4 and 5 of the Data 1H pack. So it starts off with definitions for what mode, median and mean are, and also range. Now, mode, median and mean are all measures of average. They are some way of summarizing the data with an average value. Range is not an average, it is a measure of spread. So it tells us something else about the data. It tells us how spread out the data is. So the definition of the mode is that it is the most commonly occurring data value. I'll just put the most common data value. And we can have more than one mode. When there's two modes, two numbers that occur the most, we call that bimodal data. But for the purposes of GCSE maths, we don't go any further than that. You'll never get a question in a GCSE exam asking you to find the mode where there happens to be two modes. The median is the middle data value, but importantly, it's when the data is ordered. I'm not sure why my pen is lagging so much today. And the mean, I often think the easiest way to remember this is that it's the meanest one to find out, is what you get when you add up all the data values and divide by how many there are. So it's sum of all the data values divided by how many there are. And the range is the difference between the highest and the lowest piece of data. And to find the difference, we subtract. So it's simply the highest data value minus the lowest. Okay. Next question wants us to find those things for this data. So whether you're asked to find the median or not, it's usually a good idea to put the data in order if you don't have very much of it, because it will help with things like the range and spotting modes. So I'd recommend always putting data in order even if you're not asked for the median. So I'm just going to do these answers now, and I will edit the video so that they just appear and you can pause and mark your work. Here are the answers to question 2. I guess the first couple of things to mention is that there are two sets of bimodal data here. So this set here and the bottom set both have two modes. And the other thing is that the averages, be it mode, median or mean, are always between the lowest and the highest bit of data. If you think about it, they wouldn't be a very good average if they weren't. So that's one thing to bear in mind as we go on, especially to doing averages from frequency tables. Your averages should always be between the lowest and the highest piece of data. Okay, going to go through the next few questions on the page. So on number 3, we're told that the mean of 4 numbers is 10 and three of the numbers are 9, 11 and 7. We've got to find the other one. Now on questions like this, if you're given the mean, you can work out the total of what they all added up to. If you think about it, to find the mean, we would add all of these numbers up. So we would do 7 plus 9 plus 11 plus this missing number, let's call it x. And then we would divide by how many there are. It's 4 of them, and we would get the mean. And they told us that the mean was 10. Now if we reverse this, if we hadn't have divided by 4, the answer would not be 10, it would have been 40. So we know that all of these numbers have to add up to 40. and therefore it's quite easy to figure out what the missing one is. So 7 add 9 is 16, plus 11 is 27, so x must be 13. Okay, you don't have to use algebra to do it, but that's just a kind of good way to show it. On number 4, we've got two small Year 10 classes, set A and set B, and they sit the same test. Set A had these scores, set B had these scores. How much bigger was set B's mean average than set A's mean average? So just finding the mean of two listed sets of data here and finding out how much bigger one was than the other one. Nothing tricky about this one. So we would add all these first ones up. And it doesn't matter that they're percentages. Okay, and then divide by how many there are, and there are 9 of them. $65.6 recurring, so watch out for that little recurring dot above the 6. If you press that button again, that will tell you what that number would look like if we wrote a few decimal places, so actually that would round to 65.7 if we were going to round it to one decimal place. And for the other set, comes to 661, and there are 10 of those, so the answer will be 66.1. So how much bigger was set B's mean average? Well, it's good that we found that theirs was higher, so the question suggests that, but we need to do a subtraction now. And that will be 0.4. Okay. Number 5. A rugby team played 6 games. The mean score for the 6 games is 15. Now, straight away, we can figure out something there. If they played 6 games, then to find the mean, the total got divided by 6. And the answer was 15. So we can figure out what this number was here, this overall total. And the way we do that is to do 6 times 15. So I'll just undo that. And 6 times 15 gives 90. So they scored 90 points in these first 6 games. They played one more game, and the mean score for all 7 games is 16. So again, we can do the same thing. The total they scored in 7 games, so I'll call it total 2. Must be 7, because the mean would have been divided, the number would be divided by 7 to find the mean. So to find the total, 7 times 16, which is 112, I think. Okay, check that. Yeah, okay. So how many points did they score in the 7th game? Well, if in 6 games they scored 90 points, and in 7 games they scored 112, then in the 7th game they must have scored the difference. 112 take away 90 gives us 22 points. Okay, next page coming up.